Okay. So let's try and solve this daily interview pro problem. So this problem was asked by Amazon, and given a binary tree, return all values given a certain height h. So if we have this tree and the height is 3, this is 1, 2, 3, we want to return all these values. So 4, 5, 7. So we want to find the values at height. Now, when I do recursive functions, I tend to want to make an internal function just because it's sometimes it's easier. Like sometimes I want to instantiate variables outside here. And you know, if I'm doing recursion using only this one function, sometimes it just gets a little weird where you have to, you know, keep track of your values through the return statements and all that. So we want to be able to say, well, what are we going to need? It's base case, so we're going to need it's recursion, so we're going to need a base case. What else do we know about recursion? Let's just say time complexity, but worst case time complexity for a binary tree is O to the n if unbalanced, and O log n if balanced. So depending on how balanced the tree is, the time complexity, or not time complexity, space complexity. Time complexity is going to be O log n for on, because we're going to touch every node once. Okay, so that should be good. So we have recursion, we have a base case. We want to keep track of what level we're on. So when we run this, we'll put in root and we'll put in a height of 1, maybe. Let me think about this. Either 1 or 0. Our base case is going to be if root equals null, or if we don't have root, then we just want to return, we don't need to return anything. So this is when we get to a leaf. So what this base case means is when we get to here, 4, 5, 7, and maybe this is a bit small. So we got 1, 2, 3, 4, 5, 7. Sorry, this is a bit blurry, but the base case is basically saying when we get to here, right? And like, what are these values? They're all null. They don't exist. So we say, what's like the left value of this? Nothing. Right value of this? Nothing. So when we get to these nothings, what do we want to return? Well, nothing. Because what we want to do is make an array for our answer. And when we find a node on this level, that's when we want to add that to the list. So the list answer. So what we can do is we can say recurse root.left h plus 1, and we can do the same for right. So we'll go left and right and increase h, and when we get here, so the first time we put in root, we're gonna put this node in. So h will be 1 and root will be 1. And then we get left and right, and we recurse through here, and so we'll get 2 and 3, and those will have h2. So actually what we want to check is up here, and we want to say if h is equal to height, then we want to say answer.push. So we want to add root, and do we want to add the value or do we want the whole node? Return all values given a certain height. So we don't want the node, we just want to pull off the value and actually My thing is called value, not val. Okay, so just commenting. You know, we don't really need these comments. If you found them helpful, dope. So let's think about this. So this looks good to me. We have our answer, we have our root, we have our height. We say if h equals height. Now, because this function is inside this other function, we have access to height. So we can just say height like this. In other languages, and maybe it's best practice, I'm not exactly sure, but you would pass height into here. And this just ensures that, like, if you move this function out of here, that, you know, you could still pass in this height. So it parameterizes the function. It sort of makes it allows you to move it outside of here. So, you know, a little unnecessary in this case, but always worth considering. Yeah, so I'm going to run this because I think it looks good. And I returned an empty array. Okay. Oh, I didn't update these. Was that the only issue? That was the only issue. So you see here, the answer is supposed to be 457. So that looks good to me. So that was this question for Daily Interview Pro. Good luck with your own interviews. Have a nice day.